Sea level can affect the coastline. These are referred to as eustatic changes and can be measured all over the world. They can be a result of a change in the amount of water, which can be lower during periods of global glaciation or during the ice ages, where much of the water is frozen in ice. So the amount of water, liquid water in the oceans is lower, and therefore we have a lower sea level. For example, this graph shows the sea level rising from 20,000 years ago, so post-glacial sea level rise. The last ice age occurred more or less 18,000 years ago. And so the most of the water was frozen. And as we came out of that ice age, the sea level started to rise. It's the water that was frozen on the glaciers and in the ice caps started to melt and enter the ocean, raising the sea level to its present level of today. We estimate that the sea level rose between 1 and 2.4 millimeters per year over the last 4,000 years. This graph shows sea level projections for the future for 2050 and 2100. Because the global sea level projections face a lot of uncertainty, there are different scenarios that are provided, with the lowest sea level rise, the intermediate low, an intermediate high, and the highest sea level being projected. But even the most conservative of these predictions estimate a 20 centimeter sea level rise for the year 2100. And the least conservative scenario estimates that the sea level will rise up to 2 meters of today's sea level. The southeast coast of the US in the past, and in the past, over here on the right, so you see where the sea level was during the last ice age and relative to the cities of Miami and New Orleans. And on the right, you see the projection of the sea level by the year 2100. And you can see the cities of Miami and New Orleans underwater. Again, this diagram shows the change in the sea level 18,000 of years ago, so during the last ice age. In the green line, all the water was frozen in the ice caps and glaciers, so there was less water in the oceans, and therefore the sea level was at a lower location. At 18,000 of years ago, the purple line, and the future sea level indicated by the dashed black line. Other changes to the sea level can be as the volume of the ocean container can vary. If you think of the ocean basin as a container, that volume can change as a result of seafloor spreading. If we have more seafloor spreading, then we have an increased basin size. Also, the sediments shed by the continents can then decrease the size of the ocean basin. If we're filling that basin with sediment, we decrease the size of that basin. If you have a bucket and you fill it up with sand instead of water, the amount of space that the bucket could have to hold water has been decreased. Volume of water can also change as temperature varies. Warm temperature expands water, so that will lead to a sea level rise. And then we have local changes to the sea level, and those can be a result of tectonic or isostatic adjustments that can change the height and shape of the coast. Wind and currents, storm surges, El Nino or La Nina can also force the water against the shore or draw it away, creating local changes in the sea level.